What's up, everybody? This is Aircrete Harry, and today's going to be a follow-up to the previous video I made talking about the Aircrete thickening agent. So I got a comment from Ernest on my last video requesting I test these two samples here from top to bottom with the push test. So I thought that was a good idea, and at the same time I just wanted to go over some of the different mixers that I use. So I want to go over this because people out there who are going to attempt to replicate this system, they're going to have to use the same tools that I use if you want to get the same results. You can't use, for example, a single paddle mixer if I'm using a double paddle mixer and expect to get the exact same results. Okay, because your mixing times are going to be completely different. So I just want to go over a few things with making Aircrete, some really good tips. I never made a dedicated video to this. The interview video I did with Alosha, I speak about all these different tips, but I'm going to break them down here and now. So when making Aircrete, whether you're using a thickening agent or not, the number one rule, right, the number one thing you want to have is soft water. If your water's hard, it won't allow foam bubbles to build up and definitely won't allow them to stay. So you'll find when you're making Aircrete and your foam bubbles are collapsing, it's because you have hard water. Hard water has nothing to do with your pH. We don't care about the pH balance of the water. So what you want to do is get yourself a hard water tester and test your water. So if you click in the description below on my Amazon link, or just go to aircreteharry.com under Aircrete tools, it'll take you to my Amazon link where I have hard water testers that you can purchase, as well as the same equipment that I have here you can also purchase, like this mixer. So once you know you have soft water, most of the time rainwater can be soft depending on where in the country you live in, how much pollution is in the air or not. Usually rainwater will work and it's not hard, but either way, if you're having trouble making Aircrete and getting your Aircrete to stay and keep it from collapsing, most likely it's the water issue. So what you want is soft water. So once you could get yourself soft water, you're halfway to making good Aircrete. Your next thing you need is foam solution. Now, I showed in the previous video the Aircrete thickening agent that I made this column of Aircrete with 7th generation dish soap. Now, I've done videos in the past, if you look at my previous videos, where I did a comparison between Drexel and a number of other dish soaps. And so the Drexel outperformed all of them. Now, the Suave shampoo was also a really good performer as far as making foam and keeping the density strong. But the thing to remember is all of these detergents, the hair shampoo or soap detergent for your dishes, they have citric acids in them usually. And these citric acids are part of what's breaking the foam bubbles down. Remember, they were designed for cleaning, not for foaming. So I use Drexel foaming agent. This is FM 160 because this 1 gallon container here will make you 160 gallons of foam solution. So it's really good. So in a 5-gallon bucket of water, just 4 ounces of this stuff is needed to get a really dense foam that's really good for making Aircrete. So I know a lot of people in other parts of the country, other parts of the world, can't get a hold of this, and there are a number of ingredients out there, different dish soaps that you can get in whatever country you're in that works. And you might have to do a combination of a soap and a glycerin. And to be quite honest, I have not experimented with those because I was able to find this. And for my personal use, I said, well, once I found what worked, I'm just going to stick to it. And that's what I've done with this Drexel. Now, I've bought in the past almost a $5,000 commercial foaming machine with commercial foaming agents. And I did a comparison between the commercial grade stuff to the foam generator I make using Drexel, and it actually outperformed the commercial grade stuff between the foam generator and the foaming solution. So I'm very happy with the Drexel. In concentrate, it's well, you're not using this in concentrate. You know, you're only using 4 ounces to 5 gallons. So anyway, it turns out to be really good. So once you have your soft water and you have a good foaming agent, and if you're in the US, I recommend Drexel. It just works really good. Your next thing you want is a good mixer. So I have a number of mixers here that I've experimented with. And so, like most of everyone out there, you usually start off with one of these paddles and a drill. And the drill's good because you have a forward and reverse option on drills. This here is a paint mixer / mortar mixer, and it works great for what it's designed for mixing paint and for making mortar. No problem. The issue here is we're making Aircrete, and so what we have is foam that we're trying to fold in to our cement slurry. So I find this one does not work as good as either of these other two options next to it. So next we have another double paddle mixer here. And this brand, it really doesn't matter. Again, these mixers only have one direction, forward. They have a high and low switch here on the side here for high speed and low speed. And then they have an adjustment knob here that you can adjust the speed. So they're very good. And the one next to it is the same deal. It does exactly what this does. The major difference between this gray model here and this orange model is these blades and the direction in which they spin. So when this machine here is running, it's spinning, the blades are pulling down the material. When this one is spinning, it's pulling the material up. And when this is on high, you'll even feel that one like suck you down into the mix. I highly recommend this model here. I have it on my Amazon link in the description box below. And this mixer I've been using for years now. This is actually my second one. I burnt one out from mixing the Epic, really thick mix. And I was just mixing for hours and hours and I ended up burning it out. But this one here I've had for over a year now and it's worked great for me. Anyway, I highly recommend this mixer here because these paddles are pulling your cement slurry up. So when you make your Aircrete, there's two options you have out there. You can go with 5 gallons of water and one 94-pound bag of cement, or you could go with 6 gallons of water and one 94-pound bag of cement. I've been doing the 6 gallons of water mix, not the 5. And it's just my preference. I find it works really good for me, especially with my ingredients. I get a really good solid Aircrete and I'm very happy with it. So what you do is after you have your water in your container, you put your bag of cement in and you mix it up. And I highly recommend this because your cement's heavy and it wants to stay down. So once I begin adding my foam in it, using this mixer will pull the cement up into the foam. And that's the major difference between this one that will push the foam down into it opposed to this one pulling the cement up. I get a much better and faster mix using this machine opposed to this one, and both of these are better than the single one. I do not recommend the single mixer for mixing Aircrete. So I don't ever use this for Aircrete. In the very beginning I did, but that was until I learned about these other mixers and the difference between them. So again, I highly recommend this model here. The company Northern Tool makes them out of a plant in China. And you know, they're all probably made in China. But this particular model is the only one that I found that paddles, the double paddles pull the material up. And that's a major difference. And if you want to replicate the way I'm mixing Aircrete, you're going to have to get yourself the double paddle mixer. And you should be able to copy or get similar results to myself. Okay, so I explained how you make Aircrete with the 6 gallons, 5 gallons, or 6 gallons of water. My preference is 6 gallons of water with 194-pound bag of cement. And you mix that up into a cement slurry. Next, you add your foam. Now with Aircrete, you can get different strength Aircrete depending on how much foam you add to it, how much shaving cream foam, the foam you make with your Drexel. So depending on the amount you add, you'll get different strength as well as different insulative values. Now as an example, both of these here were made using about 50 gallons of shaving cream foam. So that's actually a little more than what's used for building domes out there. Usually a 50 gallon is made, a 50-gallon mix. So that would mean you have 7 gallons of cement slurry between your water and your cement mixed together, and then you're adding about 43 gallons of foam. This here was about 52 gallons of foam approximately. So, no, 48, no, I'm sorry, yeah, 48 gallons of foam. So this was 48 gallons of foam added to each of these because I filled a 55-gallon drum basically to the top with the foam that I added to it. So this would be considered a weaker, more insulative mix. Now my video before, I showed how I was busting this up with my hand, and it can be like that with some mixes of Aircrete. But again, you can get stronger Aircrete by just adding less foam. So it really depends on the application of the Aircrete. If you're going to perhaps fill a wall cavity with Aircrete as an insulative mix, then this mix or even more foam would probably work great. But if you're building a dome and you want some strength to it as well, then adding a little less foam will give you a stronger Aircrete brick. Not all Aircrete is like this. This is based on the amount of foam that it added to it. Now what is different is I haven't done all the testing, but I'm actually curious now as to how much foam I could add and still get a pretty insulative and strong Aircrete using the thickening agent. Because in the past I've made a 60-gallon mix as well as even a 100-gallon mix where I added about 93 gallons of foam to one 94-pound bag of cement. And it was a very lightweight, very insulative brick, but it was also very weak. And now I'm curious as to what I would get using the thickening agent in a mix like that. I think that would be really good because I'm into building domes because that's my preference. I like the dome shape. It's a 360 arch. It's very strong. Dome shape or an arch keeps your cement under compression, and that's what concrete likes. Concrete likes to be under compression, not tensile strength, right? So when you have an arch, you have the ideal geometry for concrete, for cement. Aircrete. Aircrete is not concrete. Aircrete is cement because you're only taking a cement slurry and adding foam to it. Concrete is when you add other aggregates such as sand or rock or any other type of gravel with sand combined with your cement. Then you have a concrete. A lot of times I get comments about, you know, I'm calling it the wrong thing. I'm actually not, because if we go according to the dictionary meaning of concrete, it would always say water, sand, and gravel. And so if I'm making aircrete, I'm not making concrete. I'm only adding shaving cream, foam, and water. So therefore, I continue to call it cement. Even the epic mix that I make is EPS styrofoam beads mixed with paper and cement. So could that be looked as an aggregate? I guess you can, but it's not the definition of the aggregate for concrete. So just get off my back, okay? If I say concrete or cement, just go according to what I'm mixing. If I'm putting gravel and sand and I'm, you know, in the ground or something, yeah, it's concrete. So anyway, now that we've got that off my chest, what I'm going to be doing next here is removing this plastic from the hose side here and doing another push test to see if I'm going to get different strengths as I go down. And the thought is that as I get towards the bottom, the aircrete will be stronger. And I'm going to do the same thing for both columns here. Ooh, it looks so nice and smooth down here. Okay, so the other thing I've done is added this extension bar so that I can push in as deep as this will go and get a reading. So we'll see if I get any different of a reading than my first test that I did. So I'm going to start off next to the last hole that I made with this extension and see what reading I get. I believe I had a 45 pounds of force for this hole last time. So I'm going to go right next to it and just start with this one. Yep, so it's about 45 pounds of force as well for that hole. I was just curious if the pounds of force would change pushing it in deeper, and it didn't seem to. So I'm going to actually start up top here and see what kind of reading I get. This is as high as I can reach and still get some force onto here. So I got the same 45 pounds of force. I'm going to move down approximately 12 inches. Let me redo that one. I'll go about an inch below that one. So here I'm getting 70 pounds of force. And let's check the depth on this one. It's 0.7. It's 3/4 of an inch on that one there. I'm gonna do again about 1 inch below that, where I can get some leverage on here, because that was an awkward angle for me. They're at about 72 pounds of force. It went in 3.2 inches or 83 millimeters. So I'll go down another 12 inches from there. That's about 69 pounds of force. And that went in 52 millimeters or 2 inches. So the next 12 inches is about where I did the last sample. So I'm going to go further down. About another 12 inches here. That was 69 pounds of force. And that went in 2.9 inches or 75 millimeters. So it doesn't seem to be getting stronger as I go down. So I'm gonna go down another 12 inches here. Oh yeah, now we're getting somewhere. That was 90 pounds of force. And that went in 16 millimeters or 0.6 inches just now. So that definitely seems denser there. It still went in a lot. So basically I'm gonna go to the bottom here. Actually, I can't go right there, because I actually used a sandbag to plug the bottom of these columns up. So that's too far down. So I'm just gonna go a few inches below. This is about 8 inches below the last mark. That was 83 pounds of force. And that's 1.9 inches or 48 millimeters. Now, when I'm pushing until I feel resistance and it stops. So that's my method there as to how deep do I go. I keep pushing until it stops. And that's what I've done with all these tests that I've just done. And so it does seem that as we get lower, it gets denser, which means that there was some collapsing of the foam bubbles, because that's why the density changed so much. So we'll go over to the other column here now. Zero out. I'll start high again. This is higher than the first sample I did. Make sure I don't touch anything. Okay. That was 85 pounds of force. And that went in 1.86 millimeters, or 0.0735 of an inch. I'm really just blown away at the difference in strength. I, until yesterday, never did a test with this thickening agent, and so I've just been impressed by it. So this is below the mark that I did yesterday. So this is more than 12 inches. Okay, I was able to push in deeper there. So that was 88 pounds of force. And that went in 0.2 of an inch. So a little less than 1/4 of an inch, which works out to 5.3 millimeters. So I'll go down. That was 95 pounds of force. And that went in 0.98 millimeters, or 0.0385 of an inch. So I'll go down this right above the sandbag on this side. So this is about 14 or 16 inches. That one went in. So that's 85 pounds of force. And that went in 1.1625 of an inch, or 29.53 millimeters. So I'm going to do one last push test on this sample. I'm going to go in between the last two. That was 92 pounds of force. And it went in 10.88 millimeters, or 0.428 of an inch. So as you can see, we got a few varying results. The massive difference is the depth I was able to push in. On this sample, towards the top, it went in very little, as you saw. And even where it went in deep, it didn't go in very deep. So I can see from looking at it that this sample is still wet. I could tell from the color. You may be able to tell from the color as well. I'm curious if I let this out and let it completely dry, if there's going to be a difference. But there's definitely been a difference in strength. And so that's been pretty impressive. So I'm going to actually remove these two columns from here and just lay them out in the sun, and I'll do another test in a couple of days after they've completely dried, because even touching the inside, it still feels like there's moisture in there, and it's been about 4 weeks that they've been sitting here. So that's been interesting. Anyway, that was this was Ernest's idea to do this test, which inspired me to speak about making the Aircrete, about using soft water as a very, very important step into making Aircrete. Actually, another thing I want to discuss is I was asked a question on the same video from yesterday about Styro-aircrete. Steven created a Styro-aircrete, which is using 80% styrofoam and aircrete as an insulation material. And what he's made is really great. It's a great product, great for building traditional stick frame or steel stud frame cavities. Walls were cavities that you could fill with this material. Now, it's really good because Aircrete, as you know, it needs to be in a waterproof form, a leak-proof form. So when you're mixing the Aircrete with 80% styrofoam, it's no longer Aircrete, it's Styro-aircrete. And so when you're doing that, you get something that doesn't leak. It's so much thicker that you actually have to compact it. So I think it's a really good insulating material. I got my buddy in West Virginia, Gary Weber. He's been doing his own experiments where he's added a little bit of sand to his mix. And I'm actually gonna show some photographs of the foam shredding machine that he made, being inspired by Steven's foam shredding machine made with a lawnmower engine. And we discussed this whole lawnmower engine, and it's a really great DIY project. But what I want to throw out there is, if you're going with this method based on my buddy Gary's machine that he made, I think that's more the ideal way to go, where you get yourself an electric motor and you get yourself some blades from a lawnmower and you put something together. What you're going to see in these photographs are a 55-gallon drum that was cut, and an electric motor from a lawnmower engine was attached to the bottom. Now these motors are designed to operate for a certain amount of time, and otherwise you may get overheating and things like this. I'm not really sure. I've done my own lawnmower experiment with the lawnmower I was able to get, which was cordless, which is not ideal, but I had to see how well it worked, and it works pretty good, except I'm going to do a modification on mine to match my buddy Gary Weber's foam shredder that he's made. And so by mixing the styrofoam in your Aircrete, it is a very weak product, but so long as it's going behind a wall or you're covering it like Steven did with a fiberglass mesh and a thin stucco, I think it's a really good option for making an insulative as well as structural material. I'm all about alternative building systems. Aircrete just helped me to go in that direction. From Aircrete, I started experimenting with all types of materials. I've made Aircrete with wood fibers in it, with paper fibers in it. I've made the EPIC mix, which is an acronym for expanded polystyrene paper infused cement. And so that's EPS styrofoam, paper, and cement. It's a very good structural mix. And so this new Styro-aircrete is different from what's already been done. What's been done is styrofoam and cement, but not Aircrete. So you got this really very lightweight material. So my buddy Gary is making 80 gallons of this Styro-aircrete using a half a bag of cement, using about 47 pounds of cement, and mixing 1 quart of fine sand into it, into his foam beads. He's making 80 gallons of this Styro-aircrete that he's insulating his walls with for the house he's building now. So one of the questions that I got, reason I'm bringing all this up, is the Aircrete thickener, thickening agent, good for the Styro-aircrete? And yes, my buddy Gary has made the Styro-aircrete the way Steven makes it, and then he's made it using the thickening agent in combination with a quart of sand, and he's telling me about he's getting massively different results. He's getting something incredibly strong and still very lightweight and insulative. So yes, you can use this stuff with it. I look forward to seeing Steven's future video because he ordered a gallon of this stuff as well, and I'm curious as to what his results are going to be by adding the thickening agent to his Aircrete as well as his Styro-aircrete. Anyway, that's it for now. Peace out. I love you all, and I'll catch you later.